Hello, once again, this is John Krajewski from the Wonderware Product Management Team, and today I wanted to continue on with our situational awareness series of videos and go into a topic around dashboard tools. The more contemporary ways of building HMIs are talking about a hierarchical organization of your windows into 4 levels. The first level we'll talk a bit about today, which is level 1. The level 1 windows are really intended to provide you a wide overview of the system and provide at a glance awareness of where there is action that needs to be taken. So really what you need to do is you need to have a way of effectively rolling up potentially thousands of data points into just those that are going to be the key performance indicators that identify for an operator that something may not be right or an action may need to be taken. This isn't necessarily for alarms, and there are other tools for alarms, and I've covered some of those in other videos. But really, if you're trying to understand from the process, how well is the process performing? First of all, identifying these key performance indicators is more of a business activity than it is a engineering activity. So really you want to understand what is going to affect the business performance of my system. So the display that I have on the screen, I originally put together to kind of illustrate this concept. So if you have a process, many processes have things that go into that process. So the things on the left-hand side here are things that go in. Raw materials being an example of what goes in. So I was indicating here that maybe you want to follow the ingredient quality as it's coming in. If you have a offset or some drop off in quality on the inlet side, you can be sure that you're going to have an impact further down in the process. Also, giving an indication of the quantities of ingredient that are available. So if I don't have enough to make the process run that I have, then I'm going to want to know that information. Other things that go into a process are things like energy. So here I'm showing electricity pricing and saying that, perhaps at some price that there is a limit above which I don't want to produce, and maybe it makes no sense for me to be producing based on cost. There may be other reasons around energy, things like availability of energy. Perhaps there are certain types of energy or utilities or resources that are finite, and I need to know that if I run out of them, I'm not going to be able to produce. So providing clear visibility into the impact of that is something I want to see. I'm going to shift over to the right-hand side of my screen here and talk about things that come out of the process. So here I'm talking about things like the finished product or the product or service that's being provided by this system. So just some ideas around here about things you may want to be aware of are things like product quality. Has there been a drop-off from quality? Is there something here I need to manage to address and know how this product is going to affect my markets? As well as storage levels as an example here. Do I have places to put this finished product? Because that could impair my ability to be in operation. These are just some thoughts around things that you may want to be looking at for your finished product quality. As well as I'm showing here in the bottom right-hand corner, waste. Those are things that get created by a system. Sometimes that waste could be off-spec product, but in this particular case, I'm using examples of environmental impacts. So maybe there's some carbon footprint, or maybe I have a sustainability program within my organization, and I want to know if I'm impacting that sustainability metrics that I have for my system. As well as if I'm creating waste, if waste is a normal byproduct of my process, do I have places to hold it? Do I have available storage to hold the waste? These seem like pretty logical things, but in general, what I'm showing here on the sides are just those things that go into the process and things that come out of the process. In the center, I'm just trying to give an overall of how is the process running, and is there anything that could be impacting my availability. This is kind of a completely fabricated process, but you can see just some of the things that I'm showing here. So I'm using a polar star to say that if there was some key 4 control points that would give me information about whether or not I'm actually operating. Here is actually some operating well, operating to a set point. Here I'm showing individual variables and their operational states. So if things are outside of this gray box, then I know that they're in an abnormal state. So I'm showing here this dark line on the side here is showing me where it's been over the past, I think this one's 30 seconds or so. It's actually maybe even less than that. What I can see here is my current set point, my current value, my optimal operating range, my alarm limits low and high, and my critical shutdown limits low and high. So I can quickly assess that if this thing's going outside of expectation here. Here in this gain-loss chart, I'm showing things that may be going in and things that may be coming out. So maybe flows. I may see if I've got negative or positive flows into a system, but there are different ways to use this visualization. This one here is a deviation from expected norms. So I've got here a couple temperatures, a couple pressures, a couple levels. And maybe I just want to watch those to understand if something deviates for too far from expected norms. Over here on this side, I'm actually showing these are box charts which are showing the current value, the maximum value, and the minimum value, and the average value for a certain period of time. So that I can basically know if I'm trending up, trending down, and I can get some basic understandings about that process. This section here on the end is actually showing if there is an alarm. So if there's alarms, this would be basically a stacked column chart, which would show me the distribution of the different alarms by severity in those sections of the plant, so that I can go and address them. But the key thing I would want to know in this center section is generally, am I running well? Am I going to be, is my process available? But I'm not necessarily orienting this level 1 graphic at action. Really, it's just an awareness. If I had a central control room or a process that was large enough to justify a central control room, this may be the screen that was up on the wall, the one that maybe was very rarely changed. It's the one that I always wanted to be having available. But sometimes your processes may only have one screen, and you may need to have this as just something that you would be my basic system overview. But the intention here is to be able to kind of at a glance understand, do I need to do something? Does action need to be taken? Some processes may be large enough and may require multiple level 1 displays, and some of them may actually be small enough that you may even embed some actions on your level 1 displays. There isn't hard and fast rules here, and I would say that the story has not been finally written with regards to exactly what belongs in a level 1 display. But when I started looking at this, I started realizing that we could look at other organizations and see in other industries and markets around how they've addressed this. And very commonly, you've seen tools like business intelligence dashboards. And if you look at some of the most contemporary mechanisms used in business intelligence dashboards, I'm showing some of them here on this screen because I felt that there was an absolute parallel for what we were trying to achieve. When I'm looking at my overall process, I don't need to see all the pipes and valves and pumps and motors, and I've seen that done before. Is my major overview is just going to show me every piece of equipment in one massive overview screen. That's usually a recipe for disaster when I've seen it done in that way. But really what's been trying to be done here is to provide an overall view of that process and an overall indicator of what's going on, and try to use some of these contemporary dashboarding mechanisms to allow you to convey that information in a very human readable format, in a way that you don't have to train somebody for years or months, or depending on the process and complexities of your system, that you can train someone in a very short amount of time to be able to understand what's going on and be able to make a decision or call in help when necessary. They don't always have to be the expert of everything. And so when you look at the demo that's provided here, and again I'll provide a link to the demo in the description here for this video, you'll see that I've shown a couple of examples around dashboarding. These particular examples are somewhat contrived. They've just been created by me for the purpose of visualizing how things might be done. This is an area where I think that we're going to be learning more as we go into the future. But the one thing is clear is that we can learn from what other industries have done, whether those industries be financial or medical or otherwise. These are the types of things that people are doing to provide an overall awareness of their system. Good dashboarding tools. And I think that these things have every bit of relevance in real time that they do than if you're looking at a quarterly report. Why wouldn't I be able to leverage these types of techniques for just seeing how I'm deviating from my norms in real time? This one demo page I have over here takes you through a bunch of the different dashboarding tools that we've provided. Things from like column charts or column chart pairs or even column chart triples, the gain loss chart I was talking about earlier. Here's a bar chart that auto sorts itself. This one here is a detailed value comparison chart. What this one is intending to do is to show you, this is a variable range, or it's auto scaling here. So this is the min and max on the far left here, 0 to 100, and the auto scaling range is just that thick part here of what's being shown. So this is kind of zoomed out, if you will, so that you can start to see detailed differences between values. And the green lines here are kind of the expecteds, or the set points, if you will. So how am I deviating? Where are my biggest deviations from norms? But you can turn the set points off if you don't want. The box chart here again shows mins, maxes, averages, and current values, and you can even go through and reset these statistics just by double clicking on any one of those, and you can have the statistics be reset. These are all great for comparison. So this first set is what is used greatly for comparison. If you're just trying to understand composition, here's one showing alarm distribution. So I've got multiple areas and showing the alarm distribution. It's not really effectively showing it right now because I only have one alarm in the system and it's sitting in that simulation area. So it's showing you there. But if there were multiple critical highs, mediums, and lows, I would be able to see how my alarms are distributed throughout my areas by using this tool. Again, here's a stacked column chart, which is very similar to the alarm distribution chart, but this one's more allowing me to pump any data I want in. So I've got 4 variables, A, B, C, and D, and showing the composition of those, as well as also showing them on a column chart together, so I can see as they sum all together, where's my biggest parts coming from. Pie charts are another way of showing composition. They have their weaknesses, and so I caution their use of the pie charts because it's really hard to see differences. Right now, looking at this, I don't know which is bigger, the gray one or the black one. It's not completely clear to me which is exactly there. So if you're really just trying to get a high-level idea of composition and you're not trying to get too much detail, this may still be an effective method for you, but it very well may be better, instead of using a pie chart, to use a column chart for these cases. They can consume about the same amount of space, and I think that you can more readily get information from the column chart than you can a pie chart. But we have one there, and it can be effectively used if your process requires it. These bullet graphs here in the center, these bullet graphs were basically replacements for what was commonly used on dashboarding tools, which would be gauges. Usually you have a big gauge with a needle that was rotating around, showing, whether or not you were in good, bad, or satisfactory range. But that had difficulties with whether or not it was easy to compare and other areas. So what you're seeing here, what we refer to as partial and full range bullet graphs. So the ones at the bottom are full range. You see that the minimum is 0, the maximum is 200. So we're using a line or a bar here to be able to show what is the current value. You'll notice the ones above are a partial range, so I'm only 100 to 200. And the reason we use a dot here instead of a line is that if you use a line, it can actually show you or make the operator think that certain things are inaccurate. Like this one is many, many times bigger than that one. But it's not. It's only actually 20% larger because you're only showing partial range. This particular case, these bullet graphs have been configured such that if it goes into the bad area, which is this dark space here, it automatically shows the alarm border indicator, but that can be turned off if you don't like it. These can be oriented horizontally or vertically as shown here. The parallel coordinates chart basically allows you to look at multiple variables over time and see their relationships to each other. You can either turn the time off if you want. You can actually just look at the multiple variables as a linear relationship to each other, or you can see how they're affecting each other over time. This can be a very effective way of being able to see how the process is moving. Spark lines I cover a bit in in the trending video, which was the previous video that I posted on situational awareness. You can get more details around spark lines, but here you can see that I can quickly change and adjust the duration or the period of my spark line as I see fit. In the top right hand corner, I've got something called a target graph. The target graph was actually based upon a notion of something called a coxcomb graph, where actually the radius of these pi elements changes. So it's not a pie chart. These pi, the actual angle here never changes for these. What actually changes is the radius. So what happens is that if I'm on process, or if I'm actually in range of where I'm supposed to be, I just look down and I can see everything as a circle. And I've actually even set this up so that when it gets within a certain tolerance, it'll just go to a green circle. If I see anything other than that green circle, I can assume that I probably need to look at something a little bit more closely to find out why it's not where it is, and now it's within tolerance, so it's showing the green circle. These bars here allow me to compare multiple values quickly and see how they're doing against set points and optimal ranges and their alarm areas and critical shutdown areas. And down here is the deviation chart, which allows me to kind of see how multiple variables are deviating from their expected set points or norms. These are just some examples. These are the ones that we provide out of the box. We also provide full range of polar stars, which I think I'm showing over here. The polar stars are showing. I think we have a 3, 4, 5, and I think a couple of other number of variables of polar stars which are being delivered inside of this system. All of these help you in that task of being able to take multiple values and roll them up into a single presentation, something that's very easily readable by a human. These are probably just a start. We expect that we'll be delivering more of these over time, and there's every bit of tool available in the system that you can build your own. So we hope that you'll find that these kinds of mechanisms make your assembly of level 1 displays much easier and ultimately give your operators better situational awareness and being able to control their plant. Thank you very much for your time.